Hey guys, in this Python tutorial, we're going to be programming this. What is it? It's just a triangle, but when I hit enter, a bunch of points are popping up. And it looks like they're making a shape. They're making a fractal, which is called the Sierpiński triangle. So what's going on here? Basically, we start with a triangle, and we start with a random point. Doesn't really matter what point. Let's say right there. And then over and over again, what's happening is that the computer's choosing a random corner out of these three corners here, and drawing a new point that's halfway between the old point and the corner. So let's say this is the corner that was chosen, then the halfway point is somewhere around right there. And that's our new point. And again, a corner is chosen, let's say this corner, then the halfway point is somewhere like right there. Let's say again, corner is chosen. Let's say it's this corner again, then it's halfway point like that. Now another corner, this one right here, halfway point here, oops, halfway point here is like somewhere like right there. And this happens over and over and over again until you get something like this. And it makes a really surprising shape. And so what we're going to do today is we're going to program this in Python using Pygame. Some features of what we're going to do is you can move around the points. Let's say I want to skew the triangle a little bit. If I hit enter now, you can see that we still get a Sierpiński triangle that's forming. Using what we're going to make here today, you can even try things like quadrilaterals. This time it has 4 points that it's choosing from. Hit enter here, and we can see that some more complex design comes out of it. It's still kind of a Sierpiński triangle because we still see that main triangle on the bottom and the two smaller triangles on the side like that. But the top is getting more complex. So by all means, follow along on the tutorial here, and then you can try out all the different shapes you want. Quadrilaterals, five-sided shapes, whatever you want. Okay, so I'm in VS Code. I made a new folder, so I'm just going to create a new project called maybe fractal triangle.py. And we're going to start fresh here. Now, one important thing is that you need Pygame for this. So in your terminal, you're going to need to type in pip install Pygame. Assuming that was successful and you've successfully installed that package, we can start to code. So what we're going to do at the beginning here is we're just going to set the skeleton of the program. We're going to put in everything that Pygame needs just to make a window pop up. And then afterwards, we're going to deal with all the details of making it a Sierpiński triangle and all that. So we need to start by importing Pygame to get access to all the objects and the functions that it can give us. And Pygame always requires you to initialize it. So it's pretty simple. We just say pygame.init, and Pygame is now initialized. This starts out all the methods and objects. The next thing that we need is we need to make a screen. And the way you do that is you make a screen variable, and we use this special function, pygame.display.setMode. And in here, set mode takes a tuple, so another set of round brackets, and the two entries here are the screen size. So we're going to put in the screen size here. Now, we could just say something like maybe we want a 800 by 600 window, but just to make it a little bit more readable to understand what's going on here, let's store those numbers in a variable. So we can call those variables screen width, which is 800, and the height, which is 600. And then maybe we want to keep that in its own variable, a tuple, which is maybe we call it size, and it's a tuple here, two entries. The first one is going to be screen width, and the second one is going to be screen height. I think I said size before, I meant height. So instead of directly putting the numbers in here, we can just put size in. And I know it looks like more lines of code, but it makes the code more readable, right? Now you can see, oh, okay, so what's it taking in? It's taking the screen size in, right? What's the screen size? So it's a tuple with two pieces of information, how wide the screen is and how high the screen is. Great, so we've now made the screen. The next thing to do is we're going to create what's called a clock object. This is going to let us control the frame rate of the screen. The way we do this would be we're just going to make a variable called clock, and it's going to be of type object pygame.time.clock. Okay, so we'll deal with that a little later once we start setting the frame rate of the screen. Now we need our main loop. This is going to keep looping as long as the screen is actually on our screen, as long as the window is actually on our screen here. And we do want the window to be able to close, so we're going to have a variable called running, and we're going to start this off as true. And so while running, while this variable is true, this section here, everything that's in this indented section here is going to be our main code running over and over again here. And then eventually we're going to set running to false, and that's going to close the window. Now you don't actually have to say equals equals true. You can just say while running. It's just a simpler way of doing it. It's implied that we want it to be true. Okay, so now we want the window to be able to close when you click the X button. Clicking the X button is what's called an event in Pygame. And so we have to check all the events. We have to check if that event happened. So what we're going to do is we're going to say for event in pygame, pygame.event.get. And this is going to return a list of all the events that happen in that frame. And we're going to check now if that event equals pygame.quit. If the event is the quit event, then what we want to do is we're going to set running equals false. And so now when you click the X button, which is the quit event, then the screen is going to close because this while loop's going to stop. Okay, so this is actually almost at a state where we can run the program. All we need to do now is just make sure that when we leave the while loop, we quit pygame. So we just say pygame.quit. And another thing we need to do is we need to exit the terminal. So we actually need Python to actually close, and we do that by doing system.exit. But if you just try this, you see that we have a little underline undefined. We actually need to import system. So we're going to go back up to the top here. We're going to import system, just SYS. And then now we see that system.exit's there. And so we can run it now. So if I click run, all we have is this empty window. And when I click X, it doesn't close. It doesn't close because it's supposed to be event.type here. Event.type. So the type of the event is quit. So what do we do now? If we have this window, I can't close it. I'm just going to click this little trash can here. This is going to end the terminal. And now if I run it again, and I click X, it will successfully close that time. There we go. So we now have basically the shell of the pygame window, the pygame script, ready here. We just need to now actually incorporate all the things we want to incorporate, like the dots and the lines and everything like that. So I'm going to kind of make some of the code kind of in the middle here, right? We're still kind of initializing things. I want to initialize some things to do with the shapes that we're going to have on the screen. So the first thing I just want to set the color. So we're going to just define white to be the color 255, 255, 255. So all I'm doing is I'm just making a variable called white, and it's a tuple, an RGB color, 255, 255, 255, which is the color white. You could use whatever color you want here. Just play around with whatever you want. Okay. Now we're going to define the corners of the shape. So we're going to do that here. We're going to make it in an array called corner points. Okay. So corner points is going to be an array, and each element of the array is going to be a point. So it's going to be like point, which has 2 values, another point, which has 2 values, and another point, which has 2 values. Now, how do we actually decide these values here? If the entire screen is 800 by 600, then you can kind of just start estimating these different points. Now, remember, this is 0, 0. So if you go this way, that's increasing the x value, and if you go down, that's increasing the x value. So this point right here is approximately an x value of 400 right in the middle, and a y value of, I just chose 50. For that demo that we did at the start, it just shows a height difference here of 50. And then this point right here, around 50 to the right, so 50, and it's 50 off from the bottom. So this is 600, so this is a height of 550 here, 50 less. And this is going to be the same height, so the y value is still 550, but the x value this time is 50 off from the right side, so it's going to be 750, right? The whole thing here is 800, so 50 off is going to be like that. But you can play around with these points. You can choose these numbers to be whatever you want them to be. So we're going to go back to the code here, and we're just going to put in those numbers. Now, what's a little bit important is that it's in somewhat order. So later on, we're going to connect the points with a line. So you want to write them in the order you want them to be connected with lines. So this is going to, if I put an order here, it's going to be this connected to this, connected to this, and then the final line will also connect there like that. Now, it's not much of a difference when you have triangles, but once you start having shapes with more points, you do want to just write them in the order you want the lines connected. So our first point was 50 by 50. The next point was 450. And the last point was 750, 550. So we have all of our points of our shape. Now, later on, if you want to try different shapes, you can just edit this array here. That's all you need to do is edit this array. Now, we want to draw the lines on the boundary of the shape. Right? We're going to connect these 2 points first, then these 2 points, then these 2 points. So the command to draw a line is pygame.draw.line. And let's take a look at what the input information is for this. So if we go to the documentation, pygame.draw.line, and we go to the first link here, we can go find pygame.draw.line, and we can see all the things we need to put in. The surface, which is going to be the screen variable we created, color, starting position, end position, and a width. So going back to our code right here, right? we're going to do exactly that. We're going to, first of all, create the screen. So we actually need to do this later because you see we have the screen variable defined here and we're trying to draw it here. So why don't I bring all of this, maybe including the color, I'll bring all of this a little lower just so that it's after the screen has been created. Put it right there. So the first variable we're going to have to put in is screen. Then we need to put in a color. So this is why I just said white, just for that to be the color there. You just say white. Then we need to put a starting position. So what I'm going to do is, instead of putting actual numbers in, we already put the numbers in once. We don't have to put the numbers in again. I can just say corner points 0. And then the end position is going to be corner points 1. And then the width, I'll just choose a width of 5. So I'm connecting point 0 with point 1. And you can imagine just doing this 3 times for the 3 lines. I'm going to connect point 1 with point 2, and then point 2 with point 0, right? Not 3, because there's not another index here. It's point 0, 0 to 1, 1 to 2, 2 back to 0. But what if I add more points? I don't want to edit more code. All I want is later on when I add more points, I just have to edit this. So we're going to do this instead with a for loop. We're going to say for I in range. And now, how many lines do we have to draw? Well, we have to draw the amount of lines as there are points. If there's 4 points, there's 4 lines to close the shape. So we just need the length of corner points. Okay? So this I variable now is just going to go 0, 1, 2. That's it, actually. In this case, it's going to go 0, 1, 2 because the length is 3. So it's going to go 0, 1, 2. And then for each of these I values, what we want to do is we want to draw a line on the screen in white from point I, right? So if I is 0, it's going to be point 0, to point I plus 1. If I is 0, this is going to be 1. If I is 1, this is going to be 2. But what if I is 2? This is going to be 3. That's actually no good because we don't have a corner points 3. So what we have to do is we have to actually make that wrap back around down to 0. Now there's a few ways you could do this. You could just say if I plus 1 equals 3, then you could run a special command here that's going to only going to run in that special case once we get to the end like that. But there's actually a much cleaner way of doing it, and it's using the modulo operator. So if you know a little bit of modular arithmetic, you know that if you just do the modulo of the biggest number we want is the length of corner points. In this case, that's 2. It's just going to wrap back down to 0. And that's it. So we can remove all this, and this will draw all the lines connecting the points in the order that you write them. Okay, and we still see nothing. Why could that be? Because in the actual loop, we're not drawing anything just yet. So we need to actually make it so that for every loop, it's actually trying to draw. So there's 2 commands we need for this. First of all, we need to update the display. And the way we do that is we say pygame.display.flip. And we also need to set the frame rate, control the frame rate, just like I was saying before with that clock variable. And so the way we do that is we use our clock variable and we say clock.tick, and then we put in how many frames per second. Let's say I want 100 frames per second. Now when I click run, we see the triangle. It's mostly because of this display.flip command here. It's putting that on the screen. So we see our triangle exactly like I described before, right? With these points. And if I move this point, let's say I move this point a little bit over. Let's say I make it 650. So I'm moving that top point a little bit to the right. I run it now. You see that it's moved a little bit to the right and the lines have updated correspondingly. But I'll move that back to 400 just for now, just to make it what we have. Great. So now we have the triangle drawn. Now we just need to start drawing the points. Right before the main loop, we're going to just start out with initializing the point variable. This is the point that we're going to draw. I'm just going to start it out right in the middle of the screen at 400 and 300. You have to give it an initial point. Remember the algorithm I said at the beginning of this video. You have to give it an initial point. Okay, so this is going to be the actual algorithm for drawing the Sierpiński triangle. Not sure if I spelled Sierpiński right there, but that's okay. So what's the first step? The first step is choose a corner. So first we need to choose one of the corners. So we're going to say corner num, and corner num is going to be a random number, and we're going to need to use the random package. So I'm going to import that. import random. So here I'm going to just say random dot, and then we have a function called randint. It takes in a lower and upper bound. Our points, our corners are 0, 1, 2, 3, and so on, depending on how many corners we have. So the lowest we want is corner 0, and the highest we want is corner length of corner points minus 1. So we don't actually want 3. The length of corner points is 3, but we actually don't want that to be one of the options we get. So it's going to be length of corner points minus 1. You see that the randint method has both included. So the top bound is one of the possible options, 0, and in this case this would be 3 minus 1, which is 2. So it's going to be 0, 1, or 2. So corner num is going to be 0, 1, or 2, a random choice of those. And then we actually want the point. So we're going to say the actual corner is, we're going to access the corner points array at index corner num. I'm saying corner so many times. So corner is now a random point that we've chosen. So now what we need to do is we need to calculate the midpoint between our previous point and the corner we just chose. And that's actually pretty easy to do. So to calculate the midpoint, you just take the average of the x values and the average of the y values. So we can just take the x value. So we're going to take the average of 2 points. So we're going to add 2 things together and divide by 2. So we're going to take corner 0, which is the x value of the corner. And we're going to add that to point 0, which is the x value of the point. And then divide that by 2. And then we're going to do the same thing for the y values. But it's going to be corner 1 for the y values and point 1 for the y values. And that's it. We just took the average. So that's how you find the midpoint in 2-dimensional space. Now, all we need to do is we need to make that our new point for the next go around. So it's really easy. All we just say is point equals the midpoint. So mid is a variable that just holds the midpoint. And finally, we need to draw that new point. So to draw it, we say pygame.draw. Well, if to draw a line, we said pygame.draw.line. To draw a point, it's pygame.draw.point. That's actually wrong. It's pygame.draw.circle. Again, you can look at the documentation online, but what we need to put in is we need to put in the display that we're drawing on, the color, where that point is. So we can just say point at this point. And then the size of it, just say 5 again. You can play around with those numbers. And so when I click run now, it's doing it. And amazingly, we get the Sierpiński triangle that pops out of it. The last thing that I want to add to this is I just wanted to go when you hit enter. Because it's nice to just see the shape for a second and then click enter and then it goes. So we need to still check for the event. We only want this code to run if you've activated it. So I'm going to make a new variable here called active. And it's going to be false at the start, right? Because we don't want it to be running at the start. And then here we're going to say if active, then do all this. Tab that in, right? So if active, then do all this. But we never set it to active. How do we set it to active? Well, that's another event here. So the event for hitting enter is we need to now check. There's a few steps we have to do. So we have to say elif event.type equals pygame.keyDown. So it's checking if the type is a key down event. And then furthermore, we need to check if the event.key equals pygame.kReturn. That's just the name of the return key, of the enter key. If that is true, then we need to set the active mode to. So this code right here is checking if I press the key down, if that key was the return key. If so, make active true. If active is true, do our whole algorithm for starting the triangle, for drawing the triangle. So now when I hit run, it's not doing anything, but when I hit enter, it starts all of a sudden. And there we basically have it. That's all the code. All in all, it's 70 lines of code. And you could probably make it shorter. I'll just show you that it works for changing the number of points. So if, for example, I make this 600 here, or 650, to skew the triangle over to the side, and I hit enter, you see it's the same thing going on again here. And if I add another point in here, let's say I add another one. Let's say I'm going to add a point right here. I'm going to make it, I don't know, 50, 300. So we get this kind of weird shape like that. Now notice I wrote it in order, right? So I wanted that point, which is the bottom corner, to connect to the next point, which is right there, to connect to that, to connect to that. So it is important the order you write these points in. And now when I hit enter, the same process is happening. It's not guaranteed you're going to get a Sierpiński triangle, but the same process is happening. Let's let this run for a second and just see what we get. Okay, it's a little bit of a mess, but still some pattern in there. We get this big empty region and a couple triangles around the side. It's interesting to see how when you change the shape, you get different patterns emerging. So play around with it on your own. The full script is going to be linked in the description, so if you want to just copy and paste from there, by all means. If you enjoyed this tutorial and you want to see more, let me know. Otherwise, thank you so much for watching. Bye bye.